Hello everyone. So today we are going to start our next topic. We're done with algebra for a little while and we're going to work through some ideas regarding exponents. So first thing, just a reminder, on your calculator we're going to need to use our exponent button for some of this work. Hopefully you have a scientific calculator at home. If not, there's a number that you can use that are online. To use your exponent button on your calculator. On this one, if you can see that, I hope on the video, it looks something, and I'll put it in our note, looks something like this here, has X and there's a little box where we can put the exponent. I also brought my other calculator, which has this here. It's called a tilde that we use to represent an exponent. So you might have something like that on your calculator. I've also seen on calculators where you'll have a button that looks like this here, x to the exponent y, or sometimes those two variables are the other way around, y to the exponent x. All of these will allow you to type in exponents, and we'll talk about that as we work through some of these examples. So reminder that as we start with positive exponents, which should be a review, back since grade 7 and grade 8, we've been working with exponents. Reminder that a positive exponent is used to represent repeated multiplication. So if I was to write this out in full, when I have 2 to the exponent 4, this is saying that we're taking that base number 2 and we are multiplying it by itself 4 times. So a reminder that that's what this is actually meaning. And if we were to do that, 2 times 2 times 2 times 2 would then give us an answer of 16. On your calculator, reminder that if I want to type something like that in, I would hit then 2, and I'll use my exponent button, whichever one you have on your calculator, and then I would type in the exponent and hit equals, and again, there's our answer, 16. So on our next question then, 5 to the exponent 3, you could go ahead and type that in on your calculator, 5 to the exponent 3, and your calculator would tell you that the answer here is 125. And then maybe just on the side in a different color as a reminder for our note. Okay, I'm not getting you guys to do this for every single question, but a reminder that that's what that means. We can also then apply an exponent, and that base number could be a negative. So whenever we're stuck or we're not sure what this is going to look like, we can always go back to what the meaning is. Don't forget then this means we're going to take negative 2, and now we're going to take negative 2 and multiply that 4 times. If we do that, what answer will we get? First, if we look at the signs, a negative times a negative would give us a positive. But then if I multiply it by another negative, then I would have a negative. And then if I multiply by a negative, another negative, we'd be back to a positive number. In other words, the negatives pair off to give us positives. So we'll end up with a positive answer here. And if I do 2 times 2 times 2 times 2, the same as we did here, we will end up with positive 16. Now, I want to pause there for a second because I want to go to the calculator. We need to be really careful on your calculators. Some of these calculators are going to be very particular about how you type in that question. You'll see here, if I just type in negative 4 to the exponent, sorry, if I type in negative 2 to the exponent 4, you'll see that when I hit enter, I hope you can see this on the screen, that this is telling me the answer is negative 16, but from what we just did, I know that that answer is not right. The problem is this calculator is being very particular, and those brackets become really important here. The brackets are telling you that the negative 2 is that base number, so this calculator is requiring those brackets. So if you're not sure, press pause on the video and try on your calculator. Does your calculator require brackets or not? Some do and some don't. So on this calculator, I have to make sure that I type in bracket, negative 2 bracket, so I have the exact same thing that appears here to the exponent 4. And if I hit equals, then it's going to tell me that answer is positive 16. Okay, so check your calculator and make sure that it's doing the right thing. Here then, I'm not going to write this out in full. I'm just going to go to my calculator and say, okay, and on this one I know I got to type in brackets, so there is my base number, negative 5 in brackets, to the exponent, so I'm using my exponent button, 3, hit equals, and it's telling me this time the answer is negative 125. So you may be asking, about this here, saying why did this one turn negative, but yet here we just finished talking about how this one had to be positive. Don't forget that in this case we are now taking -5, multiplying it by -5, and multiplying it by -5. If I do that, negative times negative will give me a positive number. So if I multiply just the first two, I would have a positive. Multiply it by one more negative number though, positive times negative would give me a negative answer. So we can look at the exponent, and if I have an odd exponent, it means I'm going to have an odd number of negative signs, I would get a negative answer. If I have an even exponent, I would have an even number of negative signs, and that will actually give me a positive answer. Next, positive exponents, but now we can change that base is a fraction. Okay, so again, I go back to, well, what does this mean? Remember that exponents mean repeated multiplication. So this really means that I'm taking 1/2 and I'm multiplying it by itself 4 times. But I don't want to have to write that out every single time. So instead, what I want to realize here is that this really ends up being 1 times 1 times 1 times 1. In other words, I'm going to have 1 to the exponent 4, and 2 times 2 times 2 times 2. So I have 2 to the exponent 4. So what we see is I don't have to write this all out in its expanded form. What we can do is take that exponent, and really that exponent just applies to both the numerator and the denominator in that fraction. So I will have 1 to the exponent 4. 1 times 1 times 1 times 1 is just 1. And 2 to the exponent 4, you can use your calculator, or it's the same one that I used up here. So we have 1 over 16. So my shortcut then, I don't have to write this out in full. I can just say if I have this fraction cubed, then I am going to cube the numerator and I am going to cube the denominator. And if we do that, 2 times 2 times 2, that one I can do without a calculator. And the denominator, maybe that one's a little bit trickier, so we go to our calculator and say, okay, 5 cubed equals, it's telling me my answer then is 125. Last one, doesn't matter how big the exponents get then, we can then very easily tackle this. I wouldn't have to necessarily want to write this out 5 times, but I can write this and say that I am using that exponent 5 on both the numerator and the denominator. And if we do that, we'll find out that on your calculator you will get 243 for the numerator. 4 to the exponent 5 ends up being 1024. So numbers can get quite large with exponents, that's fine. We let our calculator do the work for us. So that's a quick review of positive exponents as we work through positive base numbers, negative base numbers, fraction base numbers. There's how we would apply positive exponents. The next one I want to go to is what happens if that exponent is 0. And this one's sort of an interesting case. So if we go to our calculator and try this, what we'll see is if we do 7 to the exponent 0, we end up with an answer here of 1, and that is the correct answer. If I make the base bigger, 2,735, and I use that exponent 0 again, what we will find is that this one is also 1. And what you could do is with your calculator, you could try a number of different examples, and what you would find is it doesn't matter what that base number is, any number with an exponent of 0 will always give us the same answer. It will always be 1. At the end of the note, I will try to give you an explanation why that happens. Before we do that, I want to jump to the next group of exponents, and that is what happens if we have negative exponents. So again, when we're not sure what's going to happen, what I'd like to do is just jump to the calculator and say, well, what happens if I try to type in 2 to the exponent -5? So 2 to the exponent -5. Be careful as you're doing this. Some calculators are really particular that you are using a negative sign and not the subtract sign for this, so you may need to find where is that on your calculator. If I hit equals, we're going to get a really interesting answer here, 0.03125. So we get this big long decimal. If I try the next one, 7 to the exponent -2, here we get even a bigger decimal. In fact, this decimal continues off the screen. It never ends. I'm just going to write out the first few decimal places. I'm going to say we get 0.0204. And I'm going to say ... That decimal goes on forever. So the question is then, what's happening here? We get these really bizarre numbers. Well, here's the trick. To evaluate with a negative exponent, what we do is we rewrite the power as a fraction. Keep in mind that when I get these decimals, decimals are really the same thing as some sort of fraction. It's just that we're trying to figure out what that fraction is. So if I have a negative exponent, we know we're getting decimal or fraction answers. So I'm going to rewrite when I have a negative exponent. I'm going to rewrite that power as a fraction, and here's how we do it. We write 1 over the power, and we make the exponent positive. So let's try again. If I write this then, if I have a negative exponent, I'm going to write it as 1 over the power. But the difference is I'm not going to write that as a negative 5. I now make that positive. So this negative exponent says, hey, let's flip this thing over and write it as a fraction, and then we can write that exponent as a positive. If we do that on our calculator, now I can do 1 over, and I can use my calculator to do this denominator piece. I can say we have 2 to the exponent 5 equals, and it tells me that answer is 32. If we want to check, is this the same thing? So we got this decimal here and this fraction this time. Well, remember that a fraction really just means to divide. So to check here, I'm going to now do 1 divided by 32. If I hit equals, what we will find is that we actually get the exact same decimal that we have here. So these are the same answer, except the fraction is a bit of a nicer way to write that than this big messy decimal. If I try the same thing with the second example, as soon as I see a negative exponent, I'm going to write this as a fraction, 1 over 7, and I make that exponent positive. If we try this, then we would get 1 over 7 squared, maybe without a calculator this time, 1 over 49. Is that the same as that decimal? Again, we can verify 1 divided by 49 on our calculator, and we end up with that exact same decimal, 0.0204, and the decimal goes on forever like it did when we did this question up here. So there's the rule that we use. And again, at the very end, I'll try to explain where that idea is coming from. So if we do then a couple examples here, ones where we didn't know the answer and where we were headed. If I have, say, 5 to the exponent negative 3, again, whenever I see this negative exponent, the idea is that we change this into a fraction, 1 over 5, and I make that exponent positive. And then we can use our calculator to do 5 cubed. And if you do 5 cubed on your calculator, you'll find out that that's 125. Keep in mind that still stays as a fraction, so it's still 1 over 125. Same thing here, 4 to the exponent negative 1. Seems like an odd exponent here, but if we follow our rule, it says that if I have a negative exponent, I'm going to turn that into a fraction. I do 1 over and I make that exponent positive. And then in this case, we have 1 over 4 to the exponent 1 is just 4. We can also do this when that base number is negative. We use the same rule. As soon as I have a negative exponent, okay, I'm focusing on that. I'm not worried about the fact that the base number is negative. I'm going to turn this into a fraction. We keep the base number the same way that this state is 5, this state is 4, so our base number will stay as negative 3 in brackets, but that exponent becomes positive. And now we can go to our calculator like we did earlier, and this one I will do as a reminder. Don't forget that we need those brackets. So I'm going to do negative 3 in brackets to the exponent 4. And if I do that, I get an answer of 81. So my final answer then is 1 over 81. And then the last one here, the same idea. A negative exponent tells me to make this a fraction. 1 over negative 2, I keep the base number the same, including the brackets. Okay, I make the exponent positive, and then either through some mental math or using your calculator, if I take negative 2 and I multiply it 3 times, negative 2 times negative 2 times negative 2 will give me negative 8. So I have 1 over negative 8. And then usually with fractions, we take that negative and we just bump that up to the numerator. It's a nicer way to write this. So there's our 3 rules: positive exponents, zero exponents, and negative exponents. The last part of the note here, all I want to do is just take a quick look at why does this actually make sense? So why do exponents work this way, and does it actually make sense that we're flipping this into fractions? We can see in our calculator that it seems to be making sense, but why does that work? So what I'm going to do is I'm going to start with 2 to the exponent 1, ones that we are familiar with, and say, well, don't forget that we know that that's 2. 2 squared is 4. 2 cubed will give us 8. 2 to the exponent 4 will give us 16. And if we see what's happening here, really what happens is every time we're just multiplying this number by 2. Take this and multiply it by another 2. Take this and multiply it by another 2. If I now work backwards through this pattern to try and figure out what happens with 0 and negative exponents, so we can try and verify that this idea makes sense, if I work backwards, I would then divide by 2. If I work backwards here, I would divide by 2. So 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 gives me 2. If I now continue this pattern, does this make sense? So if I divide by 2, 2 divided by 2 gives me my answer here, which is 1. And here we are, 2 to the exponent 0. We said anything to the exponent of 0 is 1. What about our negative exponents? So if I continue this pattern, if I divide by 2, well, I can then say I have 1 divided by 2, or I can write this as a fraction, which makes sense. That's the answer that we thought we were going to get from our new rule. If I divide this by 2 again, what I should get, and if you need to picture this, I always think of this like having a pizza. If I have half a pizza, there it is, half a pizza. If I divide that in 2, I'm going to share with a friend. If I divide that in 2, I now have that piece right there. In other words, I have 1/4 of that pizza if I divide by 2. If I divide by 2 again, okay, take your quarter pizza and divide it into 2, you would now have 1/8 of that pizza. And lastly, if we divide by 2 again, we would end up with 1/16 of our pizza. And if we follow our rules, remember we were saying with negative exponents, we're going to turn this into a fraction. And I turn this into a fraction, 2 over 2 squared. Here I get 1 over 2 and I make that exponent positive. Same thing here. What we find is that this rule is making sense. 1 over 2 squared is 4. 1 over 2 cubed is 1 over 8. 1 over 2 to the exponent 4 is 1 over 16. And we can see that the same patterns that we use to develop positive exponents, if we work backwards, also make sense then for 0 exponents and for negative exponents. This conceptually is sometimes easier to understand because we can picture this actually happening. This here is a little bit tougher to understand because conceptually we can't physically represent that, but mathematically we can see that these rules do make sense. Hope that helps. Try the homework. Let me know if you're having any difficulties, and send me an email, or we can video chat or talk on the phone if you need some help. Have a good day, guys.